Hello class, today we're taking a look at our combined percents and percent problem solving readiness guide. So the first question here is from the first half of the unit, but it's important because anytime in our calculations that we have a percent, we need to be converting that accurately to decimal. Now we do have a calculator in this half of the unit, so if you'd like, you can of course use your calculator to help you accurately convert to decimal, but we need to obviously then know how to use our calculators. So if we take a look at our 0.2%, we of course know that any percent can be replaced with out of 100. So 0.2% is 0.2 out of 100. And that really is just 0.2 divided by 100, which gives us 0.002 as our decimal. Now 3/4%, 3/4 is the decimal 0.75, and we still have that percent sign. Just like before, we can write that percent sign as out of 100 and use our calculators to divide there, and we'll get 0.0075. Of course, you should also know that dividing by 100 just moves your dot 2 times to the left, so that would be another way of getting that accurate decimal. Now, likewise, if we have a mixed number, we know that our 3/8 here is 0.375, sorry. Since we have 8 and 3/8, we're going to add our whole number 8 to that, and this is our percent, 8.375%. And again, we're going to convert that to a decimal by adjusting for this percent sign. Percent means out of 100, so I'll move our dot twice to the left, and we'll get 0.08375 as our decimal. In the case of 278%, 278%, we're going to divide that by 100, so move our dot 2 times to the left, and we'll get the decimal 2.78. In case of our 0.09%, we're again going to move our dot twice to the left. We'll get 0.0009 for our decimal. So of course, you can use your calculator in that division by 100, or you can recognize our division by 100 and use the decimal 2 spots to the left. Now, our second thing here is just our basic percent of equations. And to solve these, when we don't have anything about increase, decrease, change, we're just going to go ahead and convert our words into math symbols. So what translates into our unknown translates into equals. Our 2756, excuse me, is just 2756. Percent is out of 100. Of is multiply, and then 35 is just 35. Now, in an equation, as long as our unknown is by itself, we can just calculate the other side. And of course, this question mark is in fact the only thing to the left of the equal sign here, so we can just calculate the other side. Calculating our fraction first, our 2756 divided by 100 gives me 27.56. Of course, just moving that dot 2 times. And then that 27.56 multiplied by my 35 gives me my unknown is 964.6. Tells us to round to the nearest hundredth if we need to. We don't really need to here, but we could of course throw on a 0 there to get to the hundredths place. Now in question B, we have our what translates into our unknown. Percent translates into out of 100. Of is multiply. 4.3 is just 4.3. Is translates to equals, and 75 is just 75. Now in this case, here's our equal sign. Our question mark is not by itself to the left of that equal sign. So we need to undo the things that are happening to it. I'm going to start by undoing the division by 100 by multiplying by 100 on both sides of the equal sign. I'll also undo the multiplication by 4.3 by dividing on both sides by 4.3. That'll give me my equation that my question mark is equal to 75 times 100 over 4.3. And let's do that calculation there. So we'll do 75 times 100 gives me 7,500, of course. We'll divide that by our 4.3, oops, 4.3, and we'll get this number here, 1744.1, round to the nearest hundredth, 9. And of course, we were asked what percent, so this value here is 1744 and 1900%. Final question, our 0.2 is just 0.2. Percent is out of 100. Of is multiply. What is our unknown is translates to equals, and 18 is just 18. Let's convert that fraction to a decimal. So our 0.2 divided by 100 gives us 0.002 times my unknown equals 18. And to solve this equation, we're going to divide both sides by our 0.002. And that'll give me question mark equals, well, let's see, 18 divided by my 0.002 gives me 9,000. So those are just your basic percent of equations. Question A was a type 1 equation. Question B was a type 2 equation. Question C was a type 3 equation. Next thing we looked at in the second half of the unit was starting to interpret our percent increases and decreases. And we know that an increase is just going to add to 100%. So I'll have 100% plus our 10% equals 110%. Whereas a decrease will just subtract from 100%. So 15% decrease will be 100%. Take away your 15%, will leave you with 85% left. Okay, if we have a 120% increase, we'll take our 100%, we'll increase or add by 120%, we'll get 220%. Okay, so just interpreting your percent increase or decrease compared to your percent of. So taking a look at question 4, we want to use, whenever we have a percent and a number, and an increase or decrease, we want to use the setup that our end is blank percent of the start, and we'll fill in our numbers as we know them. First number we want to fill in is our percent. So since we're increasing by 37%, we start at 100, we add 37, we get 137% of the start. Now in this case, whatever we're coming from is going to be your starting number. Right? When you're traveling from Edmonton to Calgary, it means you're starting in Edmonton. So we're going to go ahead and fill in that our start in this question is our 642. Our end is our unknown, and we'll convert everything else to an equation. Since our question mark is isolated on the left, we'll go ahead and multiply 0.37 times our 642, and we get 879.54. So we'll say our 879.54 is a 37% increase from 642. In question B, we have when blank is increased by 13%. The result is 120. Again, we have an increase and an actual number for our percent. So we'll use our start that our end is blank percent of the start. And first thing we'll fill in is that for an increase of 13%, we'll have 113% of the start. Now in this question, they told us the result is 120, and that's going to be our end number. Is our result is our end. We'll convert our percent to a decimal, and we don't know what the start number is. So in this equation, my unknown is not the only thing to the right of the equal sign. That tells me I need to divide away this 1.13. The opposite of multiplying by 1.13 is dividing. And we'll do the calculation 120 divided by 1.13. We get this long decimal here. We're told to round to the nearest hundredth if we need to. So I'll say 106.19 is equal to our unknown. In question C, we're told when 4,268 is decreased by 0.9%, the result is something. Again, we have an increase or decrease, and we know the percent number. So we're going to use the setup that end is blank percent of start. Now, since we're decreasing by 0.9%, we're going to subtract 0.9 from 100, and we'll get that we have 99.1% of the start. Again, what are we starting with? We're saying 4,268 is then decreased. So our 4,268 is our starting number. We'll convert this to a decimal. Is means equals, and our end number is unknown. So we have a calculation to do here. 0.991 times my 4,268. And that should give me 4,229.59 rounded to the nearest hundredth. Let's clean up that line a bit. 4,000. Okay. Final one in this section, our question D. Something decreased by 96% is 42. So again, we're going to set this up as our end is blank percent of start. Since we're decreasing by 96%, we're going to go 100 minus our 96 would leave us with 4% of the start. And we don't know what we're starting with, but we know that we end up with 42 as our answer. So we'll say our 42 equals our 0.04 for 4% of our unknown starting number. And we'll solve this equation by dividing away that 0.04. Calculation, 42 divided by 0.04 gives me 1050 as my unknown. Now for a percent change, when we're asked to find the percent change, or what is the percent change, we always want to apply the formula that our percent change is equal to our end minus start over our start times 100. Now again, just like always, whatever you're coming from is going to be your start number, or whatever is further in the past will be your start number. So in this case, we're going to go ahead and set up that our end is 123. We're going to subtract our start of 35. We'll divide by our start of 35, and our formula says to multiply by 100. So let's do this calculation. 123 take away 35 on top gives me 88. 88 divided by my bottom of 35 gives me this decimal, and we'll multiply by 100. And again, we're going to round to the nearest hundredth if need be. So we'll say that this is a 251.43%, and since it's positive, it's an increase. Same type of thing in question B. So we'll say our percent change equals our end minus start over start times 100. We'll fill in that our end is 120. We have to subtract our start of 126. We'll divide by 126, and we'll times 100. On top here, we get a negative number. 120 take away 126 is negative 6. Remember, the negative here is just telling you that you're going down, which we know we are, decreasing, so that's fine. We'll do the calculation. 6 divided by 126, which gives me this decimal. We'll multiply by 100, and we'll get this value. So you could say this is a negative 4.76% change, or you can say it's a 4.76% decrease. And since we are asked to label them as increases or decreases, we'll say decrease here. Okay. Final kind of just calculation topic we have is calculating percents of percents. And the key here is of means multiply. So we're going to go ahead and just translate this to an equation. Our 2% is 0.2 as a decimal, of means multiply. Our 4% is 0.4 as a decimal, of means multiply. 8,640 is just a number, so we leave it alone. Is translates to equals, and I don't know what that equals, but we can calculate it. So we'll do our 0.02 times our 0.04 times our 8640, and that gives me this number here, equals my unknown. I am again instructed to round to the nearest hundredth if I need to, so I'll go ahead and say 8.61, rounded to the nearest hundredth. Same type of thing in question B. 500% is 5 as a decimal, of means multiply. 0.2% is 0.002, of means multiply. My blank is my unknown, is translates to equals, and I end up with 25.6. Now if I look at my equation, my question mark is not by itself to the left of that equal sign, so I need to undo these two pieces here. I'm going to undo multiplying by 5 by dividing by 5. I'll undo multiplying by 0.002 by dividing by 0.002. And so let's do those calculations. We need to do 25.6 divided by 5 divided by my 0.002. And that gives me my unknown is equal to 2,560. Okay, so the first of our application topics was pretty straightforward in terms of recognizing that a discount is a percent decrease, while GST, a tax, an extra charge, is a percent increase. So if we want the sale price of a $3 item that is 28% off, and we want to write a single calculation for that, we're going to recognize that our sale price is equal to 100 minus my 28% discount, which gives me 72 of my regular $3 price. Now, if I have the final price, there's no discount in question B. I want to go ahead and add my tax. My tax is a 5% increase in Canada. And so we'll go ahead and say that we have 100% plus our 5% gives me 105% of my regular price. And of course, of is multiply. So I guess we should just put in our multiply here for our calculation. Now, of course, you could also convert your percents to decimals. So this would be 0.72, and this would be 1.05. I guess we'll just observe that this is 72% and our 105% for the written solutions. Now, if we want to do both of those together, we're just going to combine them. And since our final price is a percent of the sale price, we'll go ahead and multiply those together. So our final price will be equal to 1.05 to take care of my GST, of my 0.72 to take care of my discount, of my regular price of $3. Okay, final thing is just problem solving. So we want to go ahead and identify which topic applies to each of these questions. I'll leave question 8 with you in terms of thinking about, could a percent decrease ever be greater than 100%? You want to think about the idea of decreasing from 100%. So would it be possible to go below 0% of what you have? That will help you answer question 8. For question 9, let's go ahead and say that they're asking us for percent change. So we're going to go ahead and apply our percent change formula. Now, when we go to 180 centimeters, again, just like when you're traveling, you go to your ending place. What you're going to is going to be your end value. So we're going to go end is 180 minus 120 for our start, over 120 as our start, and times 100. 180 take away 120 is 60. So we'll do our calculation of 60 divided by 120, which should be 0.5, and we'll multiply that by 100 to get a 50% increase. Question 10, we have a product's regular price is $75.34. We want to know what is the final cost, including GST, if the product goes on sale for 16% off. So let's set up our final price equation. We know that vast majority of times it's going to start with 1.05 to take care of our 100% of our price plus our 5% GST. That's going to be of my discounted amount, and my discount is a percent decrease. So we'll go 100% minus my 16% off, gives me 84%, so 0.84 as decimal. And that'll be of my regular price, and my regular price is $75.34. Let's go ahead and do our calculation. Oops, 3, 4. And we get $66.45 rounded to 2 decimal places for our final price. Now, if the product is purchased in Ontario, which also has 7% PST, we want to know how many more dollars do the customers in Ontario have to pay. So, of course, maybe this is on sale at a national brand like Canadian Tire has stores across the country, or Home Depot, or whatever. And so we want to think about how much more do our colleagues in Ontario have to pay. So for them, their final price will be equal to their 100% of their purchase price plus their 5% GST, but also plus their 7% PST, because all of those are of the purchase price. So that'll be 112% or 1.12 as a decimal. Now their discount's the same, so they'll still have their 0.84, and their regular price is still the same. So we'll calculate what their final price is. We're going to do our 1.12 times our 0.84 times our 75.34. We get that our Ontario colleagues are paying $70.88. So we'll subtract, and we'll do our 70.88 take away our 66.45 to find out how much more. And we'll get that the Ontario folks are paying $4.43 more. And obviously you could do that subtraction on your calculator as well. Okay, question 11. Tim invested $200. By the following year, the value increased by 15%. After that, it increased by another 15% the next year, and then increased by an additional 10% the year after that. We want to know the final value of the account. The trap that you want to avoid falling into here is saying 15 plus 15 plus 10 gives me 40%. The reason we can't combine those together is that when we increase by 15%, it's compared to the start of that year. And obviously, the amount that we have at the start of the first year is not the same as the amount that we have at the start of the second year because we've increased. Okay, so we want to go ahead and kind of stack those together. So our final value here is going to be 115% of the third year. Hold on. This is year 1, year 2, year 3. But our third year itself is going to be 115% of the second. And our second is going to be 110, increased by 10%, of the first. I guess technically I have those all in reverse order, so it should really be 110% of the third year at the end there, and then 115 and 115. That's better. So overall, we're going to do our, 110% of our 115% of our 115%. And we'll convert those into decimals to do our calculation. 110 is 1.1, 115, 1.15, another 115, another 1.15, and our first year was 200. Let's do that calculation. And we have to multiply that by our 200. And we'll say that, who is this? Tim? Tim had $290.95 in his account, which notice is a lot more than a 40% increase on the original amount. Again, that's because we're earning that interest in the second year on the full amount after the first year, which means we're earning interest on the interest that we already earned in the first year. Okay, question 12. The original price of a pair of jeans was $72. On the first day, the price was decreased by 25%. On the second day, the price was reduced by an additional 10%. We want to know what the sale price was on the second day. So we know we want to combine these percents together, but the question is it 25% and then of another 10% discount? Or is it 25 plus 10 makes a 35% discount? And similar to the previous question, this actually is a percent of a percent. Every time we say we reduce or increase with a percent, it's of whatever the current value is, which might have already been reduced or increased by a previous change. So we're going to go ahead and say that our sale price, which is what we're asked for, is going to equal to our 75%. 75 comes from 100 minus my 25 of my first discount. Then I have my 90%. 90 comes from 100 take away 10. And that'll be of my regular price of $72. Let's convert those to decimals to calculate. So this will be 0.75. We'll multiply that by 0.9. We'll multiply that by 72. Get our answer. We get $48.60 is going to be my final price. Final one here says a contest is giving away 240 prizes, and it states that 0.02% of tickets will win a prize. I want to know how many tickets are sold. Since there's no mention of increase, decrease, or change here, I'm going to go ahead and treat this as a percent of question. So I'm going to go ahead and identify the key idea here. My percent of And I'm going to simplify it a little bit. They say will win a prize. Will is the future tense of did or is. And that is my amount of prizes. Okay, so I'll fill in that my prizes are 240. I don't know how many tickets are sold. Of means multiply, and my 0.02% is 0.0002 as a decimal. I'm going to solve this equation by dividing both sides by that 0.0002 to move it away from my question mark. And let's do that calculation. 240 divided by 0.0002 gives me 1,200,000 tickets are sold. So I hope that's helped you with your combining percents and your percents problem solving readiness guide.